Welcome to this presentation on how much can a human remember. This presentation will focus on the memory capacity of a human, and this is how, in this presentation, we understand the term remember. First of all, what is memory capacity? And of course, different people might have different notions of it, so let's go through some. Theoreticians might regard memory capacity as the overall storage capacity of an information processing system, which would be, in this case, the human brain. If you take a more biological orientation, you might also take into consideration constraints such as aging or the limited lifetime of a human. And if you come from a psychology view, you might be interested in the distinct memory systems and how much each of them is used by an ordinary human. And then also all of these disciplines vary in the conceptual units that they use to quantify memory. And now we come to a first possible approach of how to measure memory, which is, I have to say, an approach from the theoretician side of view. And in this approach, we compare computer memory, the human memory to computer memory, where storage capacity is measured in bits. And we translate this to the brain in the following way. Namely, that the brain stores memory in terms of synaptic strength. We translate the number of different synaptic strengths to bits, and thus the memory capacity depends on the number of synapses and the number of distinguishable synaptic strengths. How can we figure out synaptic strength? Well, the axons form synapses with dendritic spines on dendrites, and the size of these dendritic spines and the synapses can be used as proxies for synaptic strength. This is also what you see on the picture on the right, namely that the yellow parts you see vary in their size, and thus these are supposed to be synapses, and thus they have different synaptic strengths. And some studies found 26 different spine sizes and thus concluded that there are 26 different synaptic strengths, and from this they concluded that each synapse might store 4.7 bits of data. And if you now do the numbers, you might arrive at something like 2.5 petabytes as the whole memory capacity for the human brain. And 1 petabyte is roughly 11,000 4K movies, just as a reference. Then another possible approach would also be that we do not ask how much a human can store, but that we ask what is the maximal amount of information that a human will encounter throughout his life. John von Neumann estimated this to be 2.8 times 10 to the power of 20 bits. This was in the 60s, and if we update this to increased life expectancy and correct for the estimated number of neurons, we might arrive at something like 3.3 times 10 to the power of 21 bits, which would show that we theoretically would be able to roughly remember all of the information we encounter. But there are also some problems we face. The first one being that memory is split up, long-term memory is split up into different memory systems. As you can see here, we have declarative and non-declarative memory, and these split up into semantic, episodic, and procedural and reflexive memory. And all of these memory systems might work in a different manner, might store memories differently, and the memories in these systems might take up a different amount of space, so to say. Which brings us to the conclusion of the problems, that the different subsystems differ in how they store memory. We do not exactly know how to measure the size of a memory, and we also do not know how to measure whether a memory really is forgotten. So we have no way of telling if a memory really stays or if it is forgotten and thus would not take up any more space. And then also the encoding of specific types of memory might vary. And we also face the question of what do we include in our estimate? Memory that is stored, or only that which can be retrieved? Because we only can, if we work with humans, we can only measure memory that can be retrieved. Theoretically, we could also figure out some ways to measure the memory that is stored, but that is much more complicated. So all in all, we can do number games and we can estimate memory capacity to be at roughly 2.5 petabytes, but we cannot be too sure about that.